Hello, my name is Anna Mead. Welcome to this session on planning for practicals, making the most of effective investigations. The aims of this session: why do practical work in science? What is disciplinary knowledge? How to plan an investigation? How to implement an investigation? How to assess an investigation? 3 examples on planning for disciplinary knowledge. And what is the impact of teaching investigations? Why do practical work in science? Science is knowledge about the world in biology, chemistry, and physics. But how do we teach knowledge of scientific methods, scientific inquiry, working scientifically? Ashby says in her book Curriculum, hypothesis, experimental design, practical experimentation, data analysis, and interpretation are key to understanding our continuing knowledge of science and the claims made by scientists. I didn't realise how important teaching disciplinary knowledge in science was until the pandemic. Having taught science for many years, investigations have always been an intrinsic part of my planning. When we were required at my school to teach children in rows and in classrooms for a very short period of my career, I thought how easy it was to teach science using videos and children who stayed in their seats. We replanned a whole year's worth of science, calling them non-lab lessons, and realised that after a year, we maybe didn't actually teach the disciplinary knowledge very effectively. Children would come into science saying, "Are we doing Bunsen burners?" Well, we might have been using them to heat something that day, but only once a year in year 7 were we actually investigating the Bunsen burner. Reassessing the curriculum, it is important to use investigations to explicitly teach disciplinary knowledge, either before, with, or after the substantive knowledge has been taught. I'll give some examples later on in the session. The interplay between conceptual and procedural knowledge linked to substantive and disciplinary knowledge is shown here in the table. This is really useful as a tool to make the right decisions about the order you teach the knowledge. Which of the above would you teach in a particle theory or thermometer lesson? And what kind of investigation or investigations could you plan for this? Where would this knowledge sit in a whole unit or composite? And so in what order would you teach the components? As I've described previously in my session on knowledge in science, there are at least 4 areas of disciplinary knowledge. Knowledge of scientific method. Scientific method is not just fair testing. This is often overemphasized. It's also modeling, synthesis, classification, pattern seeking, and experimentation. Knowledge of apparatus and techniques is using apparatus to carry out specific procedures safely. Knowledge of data analysis is the processing and presenting of data while exploring relationships and communicating results. Knowledge of how science uses evidence to develop explanations is the tentative and valid conclusions that eventually may lead to the development of laws over time. When you go forward to plan an investigation, which composite part of disciplinary knowledge are you trying to teach? What component parts do you need? What substantive knowledge is necessary before you start? You don't need to teach every aspect of disciplinary knowledge in every investigation. So, for example, an experiment on forces might purely be a prediction or writing a hypothesis exercise, and the practical itself is simply about following a predetermined method. Or an experiment on classifying objects might be to learn how to draw a results table or collect data. Many investigations will have predetermined methods. Otherwise, you run the risk of having 30 different experiments in the room. Nobody wants that. If the learning is to plan an investigation, it's not actually necessary to carry it out. Developing explanations can be taught following both practical activities and theory-based lessons. So how can we make the most of an investigation? Here are some of my top tips. Plan and manage your resources well. Check all your health and safety procedures. Train the children, setting up and packing away. Have very, very high expectations of behaviour. And don't forget to watch the time. Make sure you know what resources you have well before the lesson and practice using anything you've not used before or for a year. Make sure the children know your expectations with practical work, and only ever stop the practical work for the individuals that are not following the instructions or who need extra support, rather than stopping a whole class. That just isn't fair. It's the right of every child to study science through practical investigation, and that's how we're going to build the scientists of tomorrow. So, another point about managing the resources. If you have a tray of magnets and a tray of materials to test magnetism, as an example, what's the best way to manage these resources? You could run a circus of activities on several different tables. You could have different materials around the room that the children go and test. How do you ensure all the children don't go to the same area at the same time? How do you manage them moving around the room safely and with purpose? Do you want them to take the results table with them or keep going back to their table? You can use things like escape rooms, quizzes, clues, information. They can be posted around the room and potentially outside too. When you come to assess an investigation, what skills are you assessing? How can you assess these practical skills? Do the children understand the disciplinary knowledge? What about your data analysis? So when you're evaluating your investigation, are you following mathematical expectations for graphs, for example? The conclusion and the evaluation, are they straightforward to mark? Giving feedback that includes how to improve an investigation is always key to improving disciplinary knowledge. Here's an example from Year 2, uses of everyday materials. This builds on Year 1. Here are some of the statutory guidance from the national curriculum. Looking for the disciplinary knowledge words, things like identifying and compare, find out. In the non-statutory guidance, lots of investigative words, identify, compare, classify, record. You saw this chart earlier on in the session. For this unit, how could you fill in this planning grid? You could pause the video and have a go if you want, using the statutory and the non-statutory guidance. Here's my example of how I would have put it into this table. So if we were going to use glass as one of the materials in our investigations, this is how I would define each section in this table. Top left, windows are made of glass. Glass is transparent, or see-through might be a word that they use in Year 2. Always use the scientific terms, transparent. There's no reason to not use it. Top right, glass is a material that is hard, brittle, and transparent. Bottom left, windows are glass so that you can see through them. Bottom right, if I shine a light through glass, all the light travels through. That also defines what transparent means. That uses procedural knowledge and working scientifically. Here's another example. Year 4, sound. In the statutory guidance, we can see investigation words like identify, recognise, find patterns. Lots of opportunity here for investigations. Non-statutory guidance. Here we've got words like explore, find patterns. as well as identify and investigate. So you know what I'm going to say now. How are we going to put this in our planning grid? Here's our planning grid again. It might help you to organise your planning for investigations and structure how you would develop them. This is how I would do it. A third example, Year 6, Living Things and Their Habitats. Key learning descriptors here are things like describe, observe, similarities and differences, give reasons, based on specific characteristics. Here's the non-statutory guidance. This here helps us to inform how to teach the key ideas. There's lots of information in here to use. Planning grid on its way. And then here the way I've put it in. So looking at this again, top left, classification, giving reasons. Top right, using the keys. Bottom left, identifying from a key. Bottom right, designing a key. Perhaps that bottom right one is the last one to do because they need the substantive knowledge earlier in order to have the knowledge to design one themselves, creating being one of those higher level thinking skills. So what's the impact we hope for? What we really hope for is that we develop children who can describe and explain the world. We want to stimulate children to want to discover more about the world because we need to develop scientists of the future. And we can do this through practical investigation and scientific inquiry that primary children love doing. So going back over the aims of my session, why do practical work in science? What's disciplinary knowledge? How to plan, how to implement, how to assess. I've given you 3 examples of how we could plan for disciplinary knowledge. And we've talked a little bit about the impact of teaching investigations. Here are the references from this presentation. Thank you very much for listening. Bye-bye.